Okay, so we had some sample code that we were playing with, and this driver is really just a mishmash of a whole bunch of things to show you, for the most part, loops, which is what we were interested in this point in time. So there's all sorts of code in here to show you, oh, there's a for each style loop with some sort of if statement acting as a filter. Oh, if you want to look at a loop that does things by positional access using a traditional counted loop, there's a little chunk of code that does that. There's the idea of retrieving things by position and updating them, which is what that little piece of code is doing. There's another couple of for each loops there just to play different games with them. The idea of copying something by making a new list. So we've already got an existing list, so we copy another list so that we get our own copy, which is what that does, remove something from our own copy. And finally, we looked at the idea of trying to see whether or not we could go through the list and see if we could find a matching item. So instead of doing things by positional notation, we started to worry about, oh gee, let me go look it up and see whether or not I can find if it's there. And one of the reasons why we had to do that is the remove operation on a list is going to remove the thing that was at position 0, which means that position 1 moves to position 0, position 2 moves to position 1. Everybody moves backwards towards the beginning of the list, so positions really don't mean anything at some point, which is why we said, okay, let's search to see whether or not we can find a serial number that matches, which is what this for each is doing. Okay? So the way we did that is we said, oh, let's pretend we haven't found one yet, so there's nothing there, and then let's run through the list until we find it, setting the found motor variable when we do find a serial number that matches, and then after the loop is done, we can check to see whether or not we actually found anything. Okay, so questions about that piece of code? It's broken / inefficient in a subtle way. So what's wrong with the way it's written? It's missing something. Oh, if it doesn't find it, it just falls through and found motor is still null, so that's not the problem.
A break statement?
Because
you found me.
Yeah, so I mean, in real life, if I say, go hunt through a pile of your clothes until you find some shirt that's the least smelly that you're going to wear today, eventually when you hunt through the pile of clothes and you pull out the shirt that you think is the one and you found the most interesting one, you don't go continue looking through the rest of the pile, you take it and you run away. And so what's missing here is the sense that after we found it, all that we do is we just remember, oh, that's the one we wanted, but then we, for some reason, continue looking through the pile for more stuff. Okay? So the way that you make the loop stop is to say break, and that says, oh, okay, I found it, I'm done. Okay? Notice that that style, by the way, is essentially something like the same sort of style that we've been writing for method calls, where we've been putting in code at the start of the method that says, if there's some reason why I've hit some special case, it's time to get out. Okay? So it's exactly the same metaphor, just done in slightly different words. And the normal case is, I don't find anything, so I keep going, which is why there's no normal case written down here, which should actually appear in the code right there as the normal case. Okay? So normal case is I don't find something. Special case is, oh, yee-haw, look, there it is. Time to get out.
What's the difference between saying break or return like this one?
Return exits this function, which is main, which would end the program.
Okay.
So return is used inside a called function to get back to who called you, but break is used inside a for loop to stop the for loop from running and drop you down outside of the for loop.
You can use it inside of a while loop too, right?
Yeah, any loop basically says stop doing what you're doing and go to the end of the loop. Okay? So the pattern is still the same in that case as what we've been writing. right? Okay, except now notice there's, like I said, there's no, the regular condition is do nothing, go back up and try again. Okay, so there we go. So that's one way of doing it. Now, I said the other day that I don't like that check to see whether or not we found a serial number. Can you think of a reason why I don't like it? Let me give you, we'll work with an analogy again. The hockey season has, for some reason, decided to start up this year. And suppose that I'm allowed to go looking in the Canucks dressing room for Ryan Kessler because I want to meet him or I've got some message to pass on to him. Okay? The technique that we're using is for me to walk into the dressing room and go, oh, are you Ryan Kessler? Right? Or sorry, actually, what's your name? What's your last name? And he says Kessler, right? Okay. What's your jersey number? And he says 17. I go, okay, now I found Ryan Kessler. And I have to ask both those questions because there's two Sedines on the thing, and so I got to ask both last name and jersey number, right? So every single individual I'm going to say to you is, you know, are you Ryan? You know, what's your last name? Ryan Kessler, or you know, whoever it is, Sedine. Oh, no, that's not the right one. Okay, I'll advance to this one, right? Ask the same question, what's your last name? I'll advance to this one, what's your last name? What's your last name? Until I find the person I'm looking for.
So can you mass get serial?
Well, forget about the Java code for a second. So the basic problem with that is that it's me doing all the work. And I want to find some way where I don't have to do as much work where somebody else has to do the work. Okay? Any way that I could
Make a class.
reduce forget about the Java thing, just in real life.
Okay, someone else class. You just want.
You ask.
Yeah, call it Ryan Kessler.
Yeah, I can't do that. Somebody's got to go through the list one way or another. I mean, that's the bottom line.
Someone else do it for you.
Well, okay. So being the lazy sort of person I am, maybe I'll employ some child labor to reduce my work. So what I'm going to do is I'm going to go find an 8-year-old, and I'm going to take the 8-year-old and I'm going to buy him a Ryan Kessler jersey. And I'm going to put the Ryan Kessler jersey on him, and I'm going to bring him through the locker room. Okay? And now, as I'm walking along, I say to the 8-year-old, is this him? I got it down to one question for me, right? And the 8-year-old gets to do the work of figuring out, oh, okay, let's see, my jersey says Kessler on the back, his jersey says Kessler on the back, oh, my jersey says 17 on the back, his jersey says 17 on the back, yeah, that's him, and then he turns to me and says, yeah, that's him. Okay, so I push the work down to someone else, and now all I do is I guide them through the locker room one step at a time going, is this him, is this him, is this him? And notice that all of a sudden now I don't care what constitutes a match. All I have to do is basically supply the sample that looks like the one I want, and then the looks like I want guy is the one who does all the real work.
So is this in the interest of efficiency or just in making the code look more simplistic at the driver level?
It will eventually makes my job simpler. The second thing is that additional person that we make actually looks sort of just like exactly like a hockey player. Looks almost exactly like Ryan Kessler, right? Except it's not the real Ryan Kessler. It's not the Ryan Kessler with the correct DNA. It's the one that's basically dressed up the same. Okay, and so that moves the work to somebody else.
So you're saying that you're making a class or a profile, for example, that looks exactly like what you're looking for, and you're searching for a match.
Yeah. So this is the in real life. This is well, okay. Somebody's going to go shopping to buy something for you. What do? You hand them a sample and you say, I want one that looks like this, right? So now you've solved the problem of them calling you and asking you a bunch of questions, or you have to figure out whether or not it's the right one. It's the sample that serves as, here's, go find one that looks like this. So it's not the real one, but it's one that's close enough of match that's like, okay, yeah, okay.
Yeah, I've been in that situation. Here's the shopping list, go buy it. It's just always easier to have the wife go buy it.
It's always,
I'm always on the phone, is this the one you want?
it's gonna be always
Oh, they
easier
don't
to have a
it. Oh,
sample.
this one's not on sale. Just let her do it.
So can you ask the person guiding the child to the locker room, can you ask that person once? And have them do all the work, and then when
Oh,
they
no, well,
get the
that's a
result-
different issue. We'll get to that. Okay? But notice that it also relieves me of the responsibility of having to worry about what constitutes a match. Because I'm not worried anymore. I just take literally the item itself, you know, the 8-year-old, and pretend he's smart and say, well, okay, are you a match or not? And the 8-year-old gets to figure it out for me, so he's got all of the work. Okay? So now what happens is my thing is that I can also turn around and whatever algorithm I use isn't tied to hockey players. Because as long as I have a matching thing, I can now just, the algorithm still works. As long as you give me a matching thing, it's like, okay, match against this one, match against that one, match against that one. I'm not asking any of those questions. And so the problem with asking that question there is that it's working at too low of a level. It's working at the hockey player level, and I'm not really interested in hockey players, really. I'm interested in finding a match at this level. Okay, so I care whether it matches or whether it doesn't. So let's just change this around a little bit. Let's make, in this case, another motor that's the matching motor. And if I make a new motor object, then I have to supply the serial number that I think is going to match. Oop, I guess I should do BB just to make it consistent. Okay, and so now what I'm going to do is I'm not going to be, oop, what other parameter do I need? Oh, some other parameter. Now here's an interesting thing. Notice then when I make my looks like or matching motor, I don't care whether or not it qualifies as a real motor in the same way that I don't care whether the 12-year-old matches all of the features about Kessler. I only care that the important feature, in this case, the serial number is the one that matches. That other parameters is going to be basically ignored anyway. So I put a 0 in there to show you it's not a real thing. And then what I'll do is I'll get rid of this, and I'll change this thing to say, instead of worrying about the serial number, I'll change this to say if matching motor dot, we'll use matches for one of anything else. Change the code to look something like that. And don't worry about the name matches, we'll fix that name, and I'm just trying to give you the sense of it. So now, notice that at this level, I don't care anymore about what motors look like. The burden of what motors look like and how they match is now moved on to the motor object to decide, oh, if you're a motor and the other guy's a motor, you decide whether or not you're the same motor. Okay? Hey, 12-year-old, you decide whether or not you're the same Kessler. Not my decision. So my thing in there has nothing about motors, about the details of motors. I've pushed that detail work down to a different level. Okay? And so now what we do is we'd go into the motor class and we'd write the matches routine. And what are you supplied? If I'm a motor, what do I get to match against? What did I supply the 12-year-old that looked like a hockey player? No, but when I'm getting him to do the match, and I'm walking the 12-year-old through the list and saying, do you match? That's the question I'm asking. What am I giving him as the information?
Say BB and comma 0.
No. Careful here. not the name. I've got this 12-year-old that's my pretend hockey player, and I'm walking him through a bunch of other hockey players. So he looks like any other hockey player. He just doesn't happen to be the right Kessler. He's a match for the Kessler. So what I'm giving them as I'm walking along is another hockey player. If I spell hockey correctly. Oh, I guess I should, in this case, motor. I'm giving them some other motor that looks like you, looks like the current information. And so now we can code this as, we'll just code this as it is a match to start with. And then we'll do the other thing, the not a match. If for some reason serial number, my serial number, actually I'll do it this way. I'll get the serial number for the other guy. That's a get. And this is basically the same code we had in main. I've just shoved it one level down. So if my serial number match or is string equals is the same as the other serial number, then return true. I guess that's the exceptional condition. We'll make this one false. Doesn't matter. We'll fix it, some of this in a second. Actually, I'm going to say if they don't match. I'm going to do it the other way. If the serial numbers don't match, then it's false. Otherwise, the answer is it's true.
You're doing the same thing, just instead of being in the driver, you're taking it down to the motor
Yep,
itself.
I just moved it down to a different level so that I don't have to see it anymore.
And that, I don't really understand the benefit of that yet. But I'm assuming
There are two benefits. One, I don't have to do the work. Second one, I don't have to know anything about how hockey players compare themselves. They can match by name, they can match by team, they can match by name, team, jersey number, whatever they need to match by. Your business.
Which
Right?
I guess means you can use that.
Which
It's more
they're,
multi-purpose.
well, the other way of thinking about it is the hockey players are experts. They know how to identify another hockey player and what constitutes a match. Are we the same one? Just like fans of hockey players know how to identify who their favorite hockey player is. I don't have to know anything about hockey to play the game at my level. I just have to find one who's a fan of Kessler and say, hey, is this him or not?
Yeah.
You know, does this guy match or not? And so I've pushed the work down to somebody else, and I've let them worry about the details of how the work is done. Not interested, not my business.
Well, you're never going to ship a program with a driver either, are you?
Pardon me?
Like you don't ship programs with the driver.
I'm probably not going to ship that driver either, so this moves the work down now to a place where it's contained within that hockey player. So the other way of looking at it is who should say whether or not one hockey player looks enough like another one? Well, it's the hockey players that should decide that. I'm not really particularly interested. Notice the other thing is that now the matching in here can get more specific. So if you have a whole bunch of information, you can say this is the stuff that I think constitutes a match, and I still don't have to know. So if we come in later and we say, for motors, we add some other piece of information that says this is the same, you know, is it, you know, Ford versus GM, right, with the same type of motor, then the matching is done inside here, and I don't care. I just say, well, does this motor match the other one? Is it a replacement for? Done. Okay? You actually play this trick all the time, and you just don't realize it. I'll give you another instance of doing almost exactly the same thing. We'll go back 15 years and we'll work with paper here for a second because it's sort of maybe easier to understand. Suppose you register at Camosun, right? The very first time you register, you go fill out an application form that has this huge pile of information of everything about you. right? Somebody goes and takes that piece of paper and puts it in a filing cabinet someplace, and that's your official registration form. Sometime later, 6 months later, you come along and your phone number has changed. And so you want to get the person behind the desk who has that in her filing cabinet to update it somehow. Well, here's a way to do the update. What you do is you take a same application form that you did 6 months earlier, you write your first name and last name on, and your social insurance number or your student ID, all of just that bare minimum information on the same piece of registration paper, and you hand it to the lady at the registration desk and you say, could you go find the form that's in your filing cabinet that looks like this one? And what does she do? She goes and she runs into the filing cabinet, she searches through every one, and she does this pattern match to go, okay, that field, that. The ones that you fill in, do they match the one that I've got in my filing cabinet? Goes through them all until she finds a match for just those fields, and then comes back with the real application form. And then updates it. Okay? So it's exactly the same process that you do in real life. Okay? It's just, you don't usually think about it that way. Okay, so let's go back, now that we've got this thing, let's go back and see whether or not we actually found this thing. It should hopefully be the last line that's printed, and it still finds it. Okay? Questions about that so far? Now, the next step in the game is that it turns out that that feature of matching is so common that Java already has a standard way of doing it and a standard name for it. And now's where there's a couple of weird Java-isms that are going to come into place. Okay? The first thing that comes into place is that the find a match for you already know as equals, which we've been using for strings. Here's a string. Does this one match enough to another string to say that they're the same thing? Matches character by character in the case of the equals routine. Okay? So we're going to have to change the name to be consistent with everything else in Java. That's the does it match function. So now you have to get use of saying, does this thing match some other one? And notice it's always a partial match. Okay? It's a partial match because you're not saying, are they identical things? Because then you'd have to have the real Kessler to try to see whether or not he matches the real one. You almost never do that. When you're searching for something, you almost always have less than complete information, just enough to say, this is the minimum that makes me accept that one as being the right one. So in the case of hockey players, it's probably team, last name, jersey number is a complete match for saying, okay, anything beyond that, don't care about it. Okay, so there's equals. Now, because it's a standard that's there in any object, what do you think the standard one matches against? There's actually a pre-existing matching function. What would be the absolute certain thing that you could match against to say that they're the same? Double equals meaning they're identical. Okay? So the default is ask the question, is this one identical to this other one? And like I said, that's the case that you almost never care about. Okay? But if you leave out this function and if you don't write it yourself, then you get identical. And so what will happen to our code is it will never work if we don't write this, because since we've made one that's only similar to the one we're looking for, the default equals will never find a match because they're not identical. Okay? So you always override the existing equals, which is why we're going to put add override on it, to say I'm trying to hide the identical match and loosen up the restriction and go for a more general match. Okay? But notice add override has a problem, and it says, no, you're not overriding equals. There isn't an equals that looks like that. That's because the actual equals, I'm just going to cut that out, has a signature that doesn't look like that. It actually looks like we'll call it that. Okay? The reason the general equals has that signature is because it's perfectly legal to say, does this hockey player match that cat? Okay? And the answer is generally no. Okay? And so if you look at the official documentation for equals, it says what you should do is you should check and see whether or not you're actually matching the same type of thing. And if you're not matching the same type of thing, then you should return false to say, no, they can't possibly be equals. Okay? That was the way that what the documentation says and what most people do. The problem with that is that I've said in general, if you're trying to match a hockey player with a cat, there's probably an error in your code someplace, because it's really unlikely that there would ever be a valid reason to do that. Okay? And so you don't usually want them to match. Usually in that situation you want your program to die because there's an obvious error in trying to do that. And so we're going to leave that out, and we're not going to say dissimilar things don't match. We're going to let it die so that we can figure out what's wrong. So now we have this case of, well, if that says object, what do we do with it? Okay, and let me write it out for you. That's the thing that fixes it. It's a strange sort of line, but what it's doing on the right-hand side, the thing coming in is presumably another motor. The brackets with the word motor around it are officially called a cast, but I prefer to call it damn it. So that line says, that thing that came in, it's a motor, damn it, put it into a motor variable so I can do motor things with it. Okay? Here's another example of a real life situation. You do that all the time when you walk up to somebody. If you see a stranger on the street and you say, that's my family doctor, you put the brackets around the doctor, and then instead of being able to ask them normal people questions because you put them into a doctor variable, you can now ask them doctor questions that you wouldn't normally ask a regular person. Okay? So that's exactly the sense of there. I know you were some general person, but now I know that you're a motor, and so now I can talk to you as if you were a motor by using motor variable dot something, and then that will work. Okay? So that's just a thing of making it more specific, essentially. And now there's your code. And so you now have a matching function. Okay? And so the rule is that if you're trying to do a partial match for something, then that's the way that you do it. Okay, questions about that? We're going to do a lot of these, by the way. After a while, the pattern always looks the same. If you're trying to just match against one thing, if this was hockey player, you would say a Boolean equals for object what, and then it would say hockey player other equals hockey player what, and then it would be, oh, get the other hockey player's jersey number. If the jersey number is a match, then I guess it's a match. Okay? So the code almost always looks the same. So I'll show you a few variations of that, but once you see that pattern, you just go fiddle with the pattern to get what you want. The only trick is you have to be careful that that thing says object. What happens, by the way, if that thing doesn't say object? Let's suppose you leave off the add override, and we'll just put in something else here. We'll put in motor, like that. That code looks like it works.
Is it gonna freak out because you're trying to type it what it was?
It doesn't matter. Even if I take that line out and put it back the way it was.
Is it only ever going to work with motor?
The trick here is that one is an equals method that has the signature with motor in it. That's not the same as another function that has the signature object in it, which is the real one you're trying to override. If you don't get the name exactly right, then it just never calls that one. And so because the other one has got a different name, so you're not overriding anything. And so the usual symptom will be, I wrote an equals method, I go and I search for something, and it's not finding it, but when I go and look, I know it's there. And that's usually a symptom that you got the wrong equals. Okay? So the official signature always has to match that thing. And so basically you always do those two lines at once when you start your equals method, and then it won't be a problem. Okay, so there's the equals method. Any object that wants to do a partial match needs to write that thing, and then you end up with code that looks like this. Okay. So now let's take the next step. How often do you think that happens? All the time. I've got this list of people in my address book. I've got 1,000 people in my address book. Oh, I want to update Fred's information. Oh, let me go search through the list until I find Fred so that I can drag him out and update his information. You do this over and over and over again. Let me go through a list and search for something, and usually the searching is so that you can immediately update it afterwards, change it in some way. Okay? So, well, there is the loop there. So what would happen is you would write the same code over and over and over again, and so there's actually a shortcut for it. Okay? So who should have the shortcut? Well, look, there's all motors there. Let's put all of that code into all motors as an extra feature so that you can do all motors dot index of, and we'll still pass in our matching motor. And all motors dot index of gives back to you the thing's position on the list. Now, assuming you found it, we'll talk about not found in a minute. What you'd have to do is retrieve it. And then you would do something like, call it motor to change actually. And then you do something like motor to change dot whatever we want to do, add hours. Okay. So here's the problem with those Java guys. See that name, index of? It's the worst possible name imaginable, because the person who wrote that routine is thinking, oh, the important thing here is that I give you a number back, its position on the list. Is it number 0, 1, 2, 3, 4 on the list, so that you can then proceed to retrieve it on the next line. Okay? An unfortunate thing is that's telling you, oh, I'm giving you a number back, but it doesn't tell you anything about what it actually does. And so the word index of should really have been, the function should have been called find a match for. And the thing that you pass in is something that looks similar to the one you want. So equals should have actually been called is similar to or looks enough like, and index of should have been called find a match for, because then it would have been find a match for something that looks similar to this one. Right? So it's a horrible, horrible name, but that thing is use equals to find a match for one. And what that does is basically that code, right? The for loop. It just goes through every single item that's on the list. It presents the fake one that you got, the match one you're trying to match against the real one, and it says, are you a match, are you a match, are you a match? Until eventually it says yes, and then it says, oh, that was the number 3 item on the list, I'll give you back a 3. Which again is sort of useless, because if you found the number 3 one, why are you making me go back and ask for it? Why didn't you just give it to me in the first place? But that's just the way the thing works. Okay, so it's almost always a 2-stage process in this version of search for. You ask the list to go search for the matching one that way, and then after the list says, oh, here's where it is, you immediately turn around and say, well, go get it for me, and then you update it. Okay. the bottom line of that is if you write the equals method inside your first level class, then you get array lists index of for free. You get searching for free, which means you almost always now are going to write an equals method in your lowest level class, because then whoever is calling you above you is going to use your work for doing the searching rather than having to do it itself. Okay. By the way, if it doesn't find a match, then position will come back as a -1, because that's an invalid position on the list. They have to be 0 through whatever. So a -1 is a sentinel value that says I didn't find it. So this code's actually missing a protected if statement to say, oh, if I didn't find it, I shouldn't update it, or I should only update it if I find it. Okay, but I'm not going to put that in there for now. Okay, so don't write this code ever again. Let ArrayList do the work for you, because it's already got a function that does that. No need to ever write it and make a mistake in getting your loop wrong. The loop's already buried inside index of. Okay? Get searching for free, basically, if you write equals. Okay, let's leave that one for a second. We'll try another thing here. We'll come back and write some more of these things with equals so that you can see some variations. What if the thing has, instead of a string, it has a couple of strings or integers and strings or some combination, so that you can see it a little more useful than just one. But now let's try a slightly different topic. We can search for things. What's the other thing that you typically do with lists other than searching them?
You sort them.
Sort them. Put them in order in some way. Okay. Let's break it down to something a little smaller than sorting them. Let's just say what I want to do is find the biggest one. Okay, because if you can find the biggest one, you can find the next biggest one, etc. So you can put them in order, right? So sorting is more or less a enhancement on finding just the biggest. Okay, so what does finding the biggest or the smallest entail for just two things? Let's break it down. Instead of a bunch of things, let's just say we're doing two things.
A comparison between two objects.
You're going to compare them and you're going to decide what makes one better than another. Okay? So the way that comparing works is you're always asking yourself, anytime you find yourself saying which one's better, which one's bigger, how about alphabetization? It's the same thing. Better means closer to the beginning of the alphabet, and worse means sort of farther away, or bigger means farther away. So smaller ones in the alphabet are closer to A, and bigger ones are farther away, and so you can still pick out where it goes on the alphabet. Okay? So it would be nice if we could find a way to do something like just comparing two objects to see which one is bigger or better. So let's go into the motor class, and let's use equals as a sort of an example here. And let's see if we can write something that does a comparison. We'll call it compare to. And rather than playing this little silly equals trick, I should remember to put add override on there. Let's just leave off that idea of that weird object thing, and let's just suppose that we're comparing ourselves to another motor. Take the easy one first. Suppose that I wanted one motor compared to another on the basis of how many hours they have on them. Just because, give me a list of all of the things from the lowest number usage to the highest usage, basically, so a number. How would you do the comparison? If I've got 50 hours on my motor and you've got 75 hours on your motor, which one's smaller?
So 0. Whichever one.
If I weigh 205 pounds and you weigh 170 pounds, am I bigger or not? How would you find out?
You would compare the two values using both their getter methods.
By what? If we're talking about weight, who's bigger, me or you? 205 versus 170.
Define big. You just subtract the two.
Subtract the two numbers. So 205 minus 170 gives me plus 35 in my direction. What if I were smaller than you?
Negative.
If it was the other way around, it would be a negative number.
Mm-hmm.
Okay? So we can use a single integer that's the difference between the two values to define how much bigger or how much smaller you are. So we'll do that way. Int difference is we'll take my current hours minus your current hours, which is other dot get current hours, and then we'll just that's get, sorry, and then we'll return the difference. We're going to make this a little fancier, which is why I left it this way. Okay, and a quick show of the usage. I think I've still got motor A and motor B kicking around here someplace at the top. I've got A motor and second motor, right? Compared to second motor. And then you would write an if statement. If difference is greater than 0, then you'd say something like just write it out really quickly. A motor is bigger than by however many hours plus the difference. Something like that. That's not totally complete, but you get the idea. Okay? And notice what's happened here. I'm not, just like with equals, I'm not worried at all about how to compare two motors to find out who's bigger or smaller. All that I do is I introduce one motor to another motor and say, hey, you decide if you're bigger or smaller than him. And notice I don't care how a motor decides whether or not what makes them better or bigger or smaller. I just ask the question. Okay? Not worried anymore, push the work down. I get an answer. This guy says he's bigger, tells me by how much, great. Okay? So tomorrow what we'll do is we'll make use of that thing to finally figure out how to do sorting and searching, and we'll do some more examples of both this equals and compare to, actually writing them to show you how you can sort or search in different ways.
Is there a website or any place that I could search